Hi everyone, thanks for checking out another InfoSec Hub video. It's been a while that I made the last video, but today I will talk to you about designing secure systems. And a system is a computer system, an information system, an application, has many names. Basically, it is a database with a user interface around it that users can log into, and an admin can extract certain information on the back end to report to somebody that is interested what was happening. But that is in the basis in application. How are we going to make these applications or systems secure? So here is a cheat sheet, so 12 steps basically to design secure systems. And number one is authentication, and authentication has really something to do with user logins. If you log in, then what kind of user are you? Are you allowed to log in at the first time? Are you allowed to access certain resources, or you have viewer rights, you have access rights? Do you have rights to adjust added information? So this is authentication. But authentication really has to do with the access indeed. So what you can do is, for instance, enforce strong passwords. So, maybe 8 digits, 12 digits. And password is one factor. If you want, for instance, you enter the password, you hit enter, and they say, give me a code. That's another layer of authentication. And then we talk about multi-factor authentication. So this is one way to keep the authentication process more secure, because everybody can, well, not everybody, but when you hack into a system and you got the username and the password and you can grant it access, that's only one layer. You can add another layer by just sending an SMS, or maybe you have an authenticator app that shows you a code that you need to follow, and it's something like a smartphone that you need to have that's really specifically for this particular user that you need to have, adding another layer of security, so to speak, because it's something that you know and something that you have. So that's two layers. All right, so after the authentication, and there's just a login process to see if the user exists within the system, if the username is correct, if the password is correct. Then we go to the authorization part, and the authorization part has to do with access rights. What kind of role do you have within this system? Do you have viewer rights, which means you can view certain files, for instance, or do you have edit rights that you can add, change, maybe even delete files? That's extra authorization for when it comes to these files. So what kind of access to data you have, what kind of user role you have. Then we have certain principles like least privilege, which means that you only need the least amount of privileges for the role that you have. We don't want to give you any other privileges because they might be abused. We give you the least amount so you are able to do your job, especially when we talk about very delicate information, maybe financial information, medical information, those kind of things. We want the least amount of privilege for the people that are working in those systems, because many stories float around that when people have too much authorizations, they will abuse it, because that has something to do with power and people, and we see how that goes in the world. So the least privilege is that's just a method of dealing with this. And on top of that, we have a list of users. This amount of users is granted this amount of rights, this amount of rights, this amount of rights, and that's one time, at one point in time only. You need to review those access rights. So we need to see, okay, right now, based on the current job that you have, on the tasks that you have, this is a great authorization. but in half a year we might think different because the company changes, roles and tasks change. Maybe your function doesn't exist in 1 year from now, so we regularly need to review your authorizations. All right, so we move to encryption. And encryption goes both ways. So we have encryption, and that's encryption of data, masking the data, encrypting the data so it's not readable. We do this because many systems are connected to the internet. This kind of data flows in and out of the system, and we call this data in transit. And data in transit should be encrypted. And it is encrypted by TLS, transport layer security, which is basically HTTPS, so the HTTP protocol, which is secured. So all data that goes through the browser, you've been watching this video now also through YouTube. This is also going through HTTPS security. So all this data in transit is secure. We want secure communications, and we want secure data protection for sensitive data. That's data at rest. When you pull a request from a web server, it needs to be encrypted, and that's data in transit because it travels between the server and the client. That data might come out of a database, and that's one storage point that is static, in the form of that it doesn't change the location. The location is static. The database itself is not, because things will be added, things will be deleted. But everything that's added or deleted need to be encrypted. And we call that encryption at rest, because that's actually sitting somewhere within a database or, a file archive, whatever it might be. And it needs to be encrypted as well, because if somebody steals the database, steals the files, it still needs to be encryption on it, making sure that the attacker that he cannot read that without cracking the encryption. So that's data encryption, either in transit, either at rest. Very important. So TLS for data in transit, what we talked about, and for sensitive data, we also have encryption like AES or something like that. We also have key management, that we make sure that we have the keys somewhere stored safely, in order for us to also unlock the data in case that we have backups of the database and we want to do a restore, and we actually want to see if the data still matches, it's not corrupted or anything. We need to have keys to decrypt the data. All right. So when you talk about a information security system, we also talk about vulnerabilities. Systems are usually built out of millions of lines of code. There might be third-party libraries involved there as well. Every line of code could possibly introduce a vulnerability. So we need to stay on top of that. We need to make sure that we are alerted of this. And there are various tools out there that can do it. We had this whole OWASP, the Open Web Application Security Project, that has the top 10 of vulnerabilities when it comes to web applications. They also update their rule set. We have various tools when we see what kind of ports are open, is any server leaking any kind of data. Anyway, vulnerabilities. And vulnerabilities is, we have this kind of thing that is not really 100% secure, and a third party could manipulate it and gain access to the system, get authentication, authorization, and with this authorization is maybe able to access a database, copy a database, delete a database, adjust a database, anything that you don't want from an outside source. So vulnerabilities will be introduced in a system when it gets updated, when it gets patched. That's where we have security patches to kind of put a band-aid on vulnerabilities. So if you want a secure system, make sure that you also patch it regularly, and at first make sure that you have some kind of vulnerability scanner going on. Then we come to part 5, audit and compliance. That's something I'm well known of because that's part of my job. Auditing and compliance is very important because that's basically the whole workflow when it comes to keeping systems, tools, people, the organization secure, because audit gives you a baseline of things that you should look at, what should be secure, and also when there are certain findings, minor findings, major findings, what you should do in order to kind of close that security gap, so to speak. So audit and compliance is also very important. We have things like ISO standards, which is international. The GDPR is a European framework for privacy, which is also important, of course, because all organizations that are processing personal information, they need to comply with GDPR, especially when they operate within the European Union. So that's also kind of a compliance framework. And we see here comprehensive logging. Yeah, logging is also very important in order to kind of have a trail, a paper trail, in this case, a digital frame of what happened. If there's a security incident, you want some logging to see, okay, there was something rattling at the door. Then they made a step from this point to that point to that point. Then something happened with the CPU. Then something happened with the RAM. You need to go back. This is kind of digital forensics to see, especially during a data breach or cyber attack, that how were they able to infiltrate our system. So that's also important. Then we go to network security. All these requests from the attacker or from the normal people outside here in the internet world, they go over the network. We talked about HTTP, HTTPS, and that's the protocol to fetch and retrieve data, send data over the internet. But network security is also very important. You can have network segregation, so you can have certain vertical LAN. You have one physical LAN, but you can have certain vertical LANs, VLANs, virtual LANs, sorry, that one. So let's say, for instance, you have a server VLAN, you have a client VLAN, you have a management VLAN. So you separate what kind of computers are able and allowed to connect to each other. And when you have a management VLAN, only the management VLAN is able to connect to the servers, not the client VLAN, not the printer VLAN. They have no business connecting to a server. So in that way, you kind of segregate the network, and because the network is just like a freeway, basically. Hundreds and thousands of cars can run through it, and they can go to all kind of directions. Fantastic. But they're not allowed to, because there are certain parts of the city that you're not allowed to go through. And only when you take a specific route where a car drives once a hour, he can access. And only because he drives that lane. So all the traffic from that lane is allowed to that spot. That's what a VLAN is. Also, secure DNS is something that's very important. I mean, we don't want no DNS poisoning. I think I made a video about this as well. Network security is very important because a lot of requests go over the network, and we want that secure as well. Terminal security, I think terminal has more to do with the command line of a system. When you have a Linux box, for instance, we use the terminal to, let's see, terminal, employee laptops. Well, this maybe also has something to do with terminal. It's an old term, but terminal has something to do with the endpoint then. So we need to protect employee laptops, the endpoint, whatever you have, a Windows or Mac machine. We need to make sure that the disk is encrypted, for instance, so when it gets stolen, data cannot be retrieved. We need to make sure that there's some antivirus on it, maybe even a firewall on the endpoint, so that we don't have no incoming connections coming in there, or we only want outgoing connections, just as an example. So terminal connection is also important because engineers will interact with the system through a terminal. Emergency response. So let's say, for instance, your system is under a DDoS attack, denial of service attack. How do we mitigate this? Is there a way to have some anti-DDoS protection? How do we respond in case of a data breach? Do we have a procedure for that? If there is a data breach, can we stop it? Can we go back to the latest backup within an X amount of time? That's also very important. So this is basically when there's an emergency, the system is down, it's been hacked, ransomware been put on it, or some other kind of malicious stuff. How fast can we go back to normal operation? How fast can we go back to delivering the service that we said to the customers that we can deliver? Response time objective, RTO. Container security. This is something more engineering wise. I'm not 100% sure, but what I know is that you can have certain containers. When you have this function of a system working correctly, you put it in a container. When you have this working, when you have this working. So they are all linked together, but when there's a problem within one container, you have a short overview of what it's doing, and you can pinpoint much easier where the problem is, instead of going through a big program, very complex with lots of dependencies. You can containerize an application. That's what I know, microservices, but I'm not an engineer, but that's what I heard. All right, APIs. When you have an application, a web app, SaaS application, software as a service, you can have APIs, application programmable interface. So it's basically, you can connect that application to another application, and over the API, you can retrieve and send data. So you could incorporate an application into your own system, so to speak, and you have your own layout and you have your own dashboard the way you want it, but you're still able to get the information from the application as you want. Of course, there's communication there as well. Here we talk about public APIs. So for everybody, you have internal APIs, only for a limited amount of people to see, probably also based on privileges. And the design patterns, authentication 2, key management, rate limiting is also very important. I mean, how many requests can you send? Because otherwise it starts to look like a DDoS attack. If I send 1,000 requests in a second, I might, bring the performance down of the application, of the system. So we also need to put those kind of things in place. All right, so then we have third-party management. Usually it's the case, or usually in a lot of cases, it is the case that when you have an application, there are certain parts of your application you don't want to build yourself, because there's already a very good product out there that only focuses on that. So then you might incorporate a third-party management system into your own system. So let's say, for instance, in the case of you building a system that needs to send lots of email, you could build it yourself, but you could also get a third party to connect to your database, where they fetch the email addresses, or the email addresses get sent to, and then based on their servers and their capacity of sending email and their reputation, domain reputation, for instance, it goes a little bit deep, but if you want something like this, and you have a hosting provider that can only allow you to send 5,000 emails, but you need to send 100,000 emails a day, then you could go for a third party instead. And when you need to do that, you need to do a vendor check. You need to see where the data is stored, how they deal with data, how long it's been stored, where it's been stored, how it's encrypted, all those kind of things. So that's third party management. And I think when you are building a large enough software application, there's no way around it that you can not skip a third party, because there are so many third parties out there that focus on a niche, but when they focus on it and been focused on it for years, they can do it way better than you could ever do it. And you don't want to focus on it. You want to focus on your system. You want to focus on your service. So it's kind of inevitable that you have to bring a third party in there as well. Okay, the last one, it's a quite long video, but there's a lot of things when it comes to securing systems, and that's the disaster recovery. So let's say, for instance, that you're hit with a ransomware attack and they encrypt all your files from all your customers, from yourself. You cannot even enter the system no more because it's encrypted. Your authentication, your authorization doesn't work no more, so you can't access nothing no more. It's all encrypted. What do? If you have good backups, and let's say that you have backups, daily backups, incremental backups, whatever you want, if you have a backup available to you that doesn't contain this malicious code that made sure that the whole system was ransomware, then you should put that back. And what kind of return time objective are you offering? How many hours can you go back? In other words, how many progress of clients' data are you losing? 2 hours, 4 hours, 6 hours, 24 hours? This needs to be tested, and you need to have a comprehensive backup plan in place, especially when you are in the online services field, because as soon as you notice this ransomware, you want to be able to go back a couple of hours before the attack and then just put it back, and the code doesn't exist anymore. Of course, you still need to do the investigation, what happened, how were they able to access, and I hope that they also didn't encrypt your backups, because that happens sometimes. But these kind of things, disaster recoveries, business continuity plans, these things need to be tested thoroughly, because you don't want to be testing it out in the field when you do actually have a problem. You want to do that beforehand and see what you run into, so you can adjust the procedures, so you can learn from this. And this is basically, everything that you need to know about securing systems. And a system could be a simple database with a web interface, or it could be YouTube. It could be Facebook. It could be Instagram. All these applications that we use on a daily basis that we take for granted, that every time we log in, everything is so smooth and it works so fast. And, pictures from 10 years ago, they still load so smooth. There's a whole comprehensive mathematical, well thought out plan behind it. And that's, how to secure and harden systems. Because trust me, they are on the constant attack. I think a Facebook or a Google or something, they are at the top of the list of hackers to try to bring down, because that's, for some guys, some girls, the ultimate prize. But this is a cheat sheet to kind of give you an idea of what you need to think about in order to design a secure system from multiple angles, from the encryption, vulnerability, audits, APIs, disaster recovery, you name it. It's all part of this. It's all part of the system. And network security, don't forget that, because it's very important. We did a few videos on that as well. I'm not a network specialist, but network is where all the traffic flows through. So, and that's very powerful, because if you are not authorized to access the system or access the backend or access the database, then you won't get in. Then you have another challenge. So you're basically making all these extra steps for somebody to kind of hack into your system, because they need to comply with this, then they need to comply with that, then they need to comply with that. And if you're smart enough, within the first two steps, you already see what they're doing, you can see the pattern, you're being alerted, and you can stop them. Thanks for listening. I hope you enjoyed it. I hope it was useful for you, and if so, please let me know. Wish all the best to you and have a great week.